Now this is a much longer thing, 8.4, which is all, but it's also from Algebra 2, this compound interest thing, which is not bad at all. Right, it's all right. Come on, 8.4. Okay, we could have a visitor next week in our class from a Weatherford College lady might come over and evaluate me. So
Thursday?
maybe, I don't know when she's coming, but
Yeah, over here you have a class.
yeah, I know. Yes, next week. Yes. You're changing the subject. Gotcha. All right. So simple interest. Look for that word on 8.3 and get used to it, and then future value. Now these formulas will be given to you. You don't have to memorize. I don't know if you have to memorize the simple interest one or not. I don't think so. However, here we go. Compound interest just is how you make the big bucks in the world. This is how you make big bucks. Is you let your money start working for you. So in my retirement account, in the last 3 months, it made $25,000. That's not bad. That means my retirement account is making more money than I'm making. That's what you want. But I'm older, I'm getting closer to retirement. So, and that's the goal, is that eventually your retirement account makes more money than you would as if you kept working. And then you can enjoy life without being around teenagers. Not that I don't love you. Okay. So, here is the little formula, and you should have seen this before, this formula. The amount or whatever, principal, the rate, and time, okay? And it's years. So be careful of time in years. It must be in year. Okay. And then, that's okay. That's if they give you interest once per year. But most places give you interest more than once per year. That's called a compounding period, okay? And so then the formula changes, just slightly. So really you don't need this formula, this top one, if you have this second one. Because this top formula is just n equals 1. Okay, so how many times are they going to give you interest? How many times are they going to calculate interest per year? So that's n is equal to 2, n is equal to 4, n is equal to 12. And the funny one is daily is 365. No, it's 360. Sorry, 360. 360. And banks decided to do this years ago, and everybody said, "Oh yeah, that makes sense because it's just easier." Now, it's weird. But you have to think about life before computers, and they actually had to calculate stuff by hand, and it just was somebody made sense to say, "Hey, let's just make it 360." Nobody still wants to do it, but we can make it work. Okay, and then some banks use continuous compounding, and that's the one that's the easiest one, and it's this formula here, PERT. And I think I had my PERT shampoo last year. Were you there for that day? I put a little shampoo in everybody's hair, his hand, and you smelled it.
I was like, you didn't put it in my hair.
Oh, I should have. This year I'm putting it in the hair. Okay, so here we go. Here's our example. We got $10,000, and we're investing at 8%. So that's good. That's a good rate. If someone gives you 8% on your money these days, you should take it. Okay. Find the balance in the account after 5 years. So they're giving us everything. They give us the rate, they gave us time, they gave us principal. And they want to know what is the difference between annual, quarterly, daily, and continuous compounding. So this is actually 4 problems in one. So this is what your homework is going to look like. Just do this multiple times. But it's all calculated. Make sure that your answer makes sense. So if you invest $10,000 for 5 years, you will not come out with $1 million. You will not do that. Okay? So you also won't come up with $10,000.05 or $10,003. That doesn't make sense either. So let's make sense of our answers. Oh, here we go. So annual compounding is I got to do four of them. A is equal to 10,000 times. Now I'm using the very top formula. 1 plus 0.08 to the 5th power. And then it's just a calculator problem. But make sure you know how to use a calculator for these things or you'll never be able to get them. So there's what I got. I hit enter and I get $14,693.28. Okay, so that's A. Part B, quarterly compounding. So now we're going to use the second formula. And N is what for quarterly? How many quarters are in the dollar? Excellent. So A is equal to 10,000. 1 plus 0.08 divided by 4 to the 4 times 5 power. Okay, so you use N twice in that formula. Okay, so this top one's if N is equal to 1 once a year, which no one hardly ever does. This is the one that banks use. Like if you have a savings account, it's probably compounded quarterly, and they give you a penny or something.
Hey, I've actually got quite a bit of my savings account.
Good job. All right, you see my calculator? Use it twice and it comes out to be $14,859.47. About $60? I'll take $160 if they want to give me $160. I will take that every day. And then the next bank says, Bank C says, we'll do it daily compounding. So the amount 1,000, 1 plus 0.08 over 360 to the 360 times 5 years. I'm just going to copy this and change the 4 to 360. On tests, make sure you write down with the numbers plugged in, because if you have this right and then plug something in here and it's, for some reason you mess up a digit or something, then you won't lose full credit. But if you just have the wrong number, I can't give you anything. So this is correct, and then it comes out to be $14,917.58. They want to give me another $50. $60. I'll another $60. And then I want to D. The amount is equal to PERT, which is equal to 10,000 times E to the rate, which is 0.08 times 5 years. Make sure you know where the E button is on your calculators before this next test. Times Shift E 0.008 times 5 years, and it comes out to be $14,918.25. So another 75 cents or so. Sorry. Someone wants to give me 75 cents? I will take 75 cents. Okay, so there's a lot of problems with using these formulas. They're not horrible. Okay. There's a lot of problems that are like this. Which one's better? Between 7% compounded monthly or 6.85% compounded continuously? So you just figure out, do both of them, whichever one's better. Now, your homework and your teacher is going to assume that more money is better. Okay? Now, I don't want, hey, more money means more responsibility, and I don't want more responsibility in this life, so I'm going to choose the one with less money. Okay, so we're just going to go old school capitalism. We want more money. Okay, and then they take that formula. I'm not going to do that one just to save some time. That's okay. It's pretty simple. All right, they take the formula. A is equal to P1 plus R over N to the NT power, right? And they want to spin it around so that what if you were, how much money should I put in right now to get in the future some amount of money? Okay, let's say you're saving for college. Do you want to go shut that? Pause. There we go. We're back. Did you miss us? All the kids at home? Anyway, if you'll notice, we can, if we want to do this problem backwards, so to speak, we could take this whole thing right here and divide both sides by this thing. I'm not going to write it out. Okay? And so then I'd be left with P on the right side and A over this thing. And this is what they have here. Okay? Same exact formula, just in a different way. It's just been moved around. Okay? So let's say you're saving for a car. Okay? How many do you need now? Let's say you want to, 5 years from now, you want to buy a really nice car. How much money do you need to put in a bank account now to have that amount in 5 years from now?
I like crushed my car.
Okay. So here's our example. How much money should be deposited today if you have an account that earns 7% weekly? So you want $10,000 in 8 years. So here's how we're going to do it. P is equal to, all right, we want to have $10,000 in 8 years. One rate, which is 0.07, over weekly is 52. And then it's 52 times 8. Grandma just died, gave you some money, and you want to save for something in the future that you know in the future is going to cost $10,000.
My grandma had to die.
But your grandma has to die for this to happen. No, that's sad. Okay, so once again, make sure you have a calculator that has stacked fractions. Then it just becomes a nice little 52 times 8. What do you think? How much money do you think we have to put in to have $10,000 in 8?
You need to put in like 8,000.
8,000? You think 5,000? Let's see who's the winner.
4,000.
$5,714.
I was right.
$5,714.
714 and 24 cents. Okay, you were right.
You were 2,200. Okay. Anyway, it almost doubles. It's kind of nice.
That's a long time.
Were you here when I talked about my retirement account? That my retirement account the last 3 months made $25,000. Yeah. This is what you want. This is what the goal is.
Yeah, but 8 years is a long time.
It is, but what if you put it in there and you forgot about it? You took the $5,000, threw it in the bank, and you forget about
I
it.
have $10,000 in the bank.
Yeah, and they think, oh my, life is gone. Now people do this, okay? This is what people do to save for colleges, for their kids,
My aunt does it for her grandkids.
okay? I'm gonna do it for my
It's
grandkids,
like they have a savings account for each grandkid.
yeah. So, and what you do is you put it in there and you just forget about it, and then 18 years go by.
But they put money in it every year.
Yeah, that's the best way.
Like for their birthday,
Yeah.
they put money in there, but then they also get the
But what if you just had a chunk of money that just showed up at your door one day? All right, ready? Can you try this one? You don't have your calculators.
Huh?
What if you wanted $10,000 in 3 years at 9.5% compounded?
I would love to have a 9.5 monthly interest rate on it.
Yes, you would. I want $10,000. 1 plus 0.095 over 12. 12 times 3. So you'll, as you do your homework, become very, very familiar, very comfortable with these formulas. I'm thinking about checking out a calculator so that you stop using your phone calculators, especially on your homework, because your homework's not going to help. It doesn't help you if you. Anyway, maybe I'll do that.
I usually just most time
Which still won't help you on the test because that's not available on the test. Yeah, no, I don't know. I'll check y'all the calculator out. This makes more sense. All right, so how about $7,528.59? Okay, so one of these things. Ready? This is actually wrong, I think. All right, so this is 20. Yeah. Okay, so let's think about it. The answer was actually 5714.24212, and probably went on forever. Okay, if I cut that off and I just put in that amount, I will not get the $10,000. I'll get to $9,999.99 probably. Okay, I'm not going to get there. So your homework's going to ask you to round up. On these problems, we're going to round up. And they're probably going to say, take it to the nearest dollar. They're going to probably say 57.15. Now, I can tell you that there's a problem somewhere that the answer is 01, 1 penny. It's like $53 and 1 penny, and you have to go round up to $54, and it freaks everybody out. So these are questions that you actually have to round up. So this is 59, would get us there. But probably your homework's going to say round up to the nearest dollar. Okay. Nope, one more formula. Lots of formulas, and we're about done. Oh, this is perfect timing on this today, I think.
What time do we get?
In 5 minutes. So this is perfect. All right. So there's one more little formula called the effective yield. Okay. And basically, I see this as a way to compare loans. So if you get a loan at 5% for compounded weekly, and you get one at 5.25% compounded monthly, and I get one at something compounded yearly, who got the better deal? Well, we could try all three of them, or we could do this, and this is the way that undoes that, so that makes it all even Stevens. And then if you get a loan anywhere in the world, they will report this in your documents to show what type of, just so that you can compare this to other things, okay, to see if you get ripped off or not. There are people in this world that rip people off badly.
Really?
Yes.
Why?
Because they didn't pay attention in math class. Okay.
My dad's good at math.
There you go.
Okay.
All right. So this effective rate is called the annual percentage rate, or the APR. APR. And that's what's, when you get a loan, they'll say, oh, my loan's at 5%, but my APR is at 5.125. Okay, that's just the way it's calculated. And that's just a comparison thing. So, what's the effective annual yield of an account paying 8% compounded quarterly? It's actually a very easy formula to use. 1 plus 0.08 over 4 to the 4th power minus 1.
Oh, I was thinking
Which is weird. Wait, we got 1 minus 1. Can we just cancel those out? And
No.
you can't.
that.
Yeah, you have to do this stuff first. Yep. Anyway, just let your calculator do it. Don't try to do math in your head.
I said, don't worry about it.
No, I never tried.
Now, here's what people will do right here. They'll put right there and they'll hit enter. And they'll forget to subtract 1.
I mean, can't you just subtract 1?
You can hit enter and then subtract 1. So, ready? This comes out to be 8.24%. And this is what bugs you, is you just got a car loan at 8%, but the APR is 8.24%.
They're chipping me.
They're not jipping you. They're trying to say this what you got is equivalent. It's kind of a standard of 8.24. It's the same as if you got 8.24. Yes,
They're
they're jipping you off.
same number. They
One more time. 6%. Compounded monthly.
Whoa.
So you went to the bank, they said, oh, we give 6%. 1 plus 0.06 over 12 to the 12th power minus 1.
Am I wrong or did I get that right?
Is that right? Double check in your calculators, please. So then I got 6 point to the nearest tenth of a percent, 6.2%. Okay, so what is the bank going to do? They're going to say, hey, our APR is 6.2%, while they only give you 6% rate. Just be careful, okay? That's all I'm saying. Just be careful.
That 0.2 add up.
But really, you should already know. You should already know that if that rate's too high. If you're a young person with no credit and you go try to buy a car from a dealership, not a dealership, but a used car salesman who's going to finance it here on the lot, be careful, because he's probably charging you a way high percentage rate. I worked with a guy who basically paid weekly for his car. Yeah, and we got paid basically weekly, and so the guy said, I'll just cash your check for you. So he would cash the guy's check, take out the weekly month, and I said, you're paying, this is a long time ago, you're paying over $400 a month for a piece of junk car. And that's what he was doing. But he had no credit, he had no job history. It was bad. All right, that's it for 8 points. We did 2 lessons. In the future, we're probably just going to start doing this in a day. Okay?